Welcome back, everyone. In this video, I'm going to show you a very useful learning tool as well as a design tool in material science. And this learning tool is called ANSYS Granta Edupack. Let me share screen and show you. So by this time, if you look into your FNU website, McMaster website, you should be able to find a document that talk about how to install your virtual machine. And by that, this software has already been installed in your virtual machine so that you can log in and remotely control and access this Granta Edupack. The icon in the Granta Edupack would look something like that. Your version may vary with what I have. And when you click on this, you will find a welcome database. You will find a welcome page coming like that. So there are multiple things here that are actually worth looking into. And I will guide you in the first in this videos and show you the features that you can use. So you might want to do material selection using this software, in which case I suggest you to use introductory level 1, level 2, or if you are more advanced, then you can use level 3 database. So let me click on that and I will explain what they are. So this is the layout of the Granta Edupack. In my case, I'm using 2021 version. So once you click on that homepage, what you'll find is this level 1 database. You can, at any time, you can click home and you can click change database, and you will bring back to this database page. So let's just introduce you to this software, why it's important. If I click on database level 1 and I click on this, you will find there's actually a lot of material that is in this level 1. There is, I believe there is 6,000 materials and it's under these different categories. So in your lecture, you will have learned different class of material. You will learn that there's metal, there's ceramics, there's polymer, there's also hybrid materials. And then within metal, we have ferrous and non-ferrous metal. So ferrous could be cast iron, could be low carbon steel, whereas non-ferrous could be aluminum, copper, and magnesium alloy, etc. In polymer, we also have polymer and elastomer. So when we click on polymer, we have thermoplastic polymer. When we click on elastomer, we have those that are, for example, rubber and polyurethane. So let's just bring up one material as an example of showcasing what this database can do for you. If you click on this, which is called All Material Database, you click on each individual material, you'll go to the material database. Meanwhile, it is worth mentioning that if you want more information about the video tutorial, Granta, the company, have actually created a series of YouTube videos that you can check out, and they will also explain further. Here, this video, the goal of this video is just to give you an overarching idea of how this software works and what are the available database and what are the features so that you can use it later on for your particular project or particular learning objective. So the first function that you can use with this software is to check out material data. So let's say you want to find out how heavy or what's the density of aluminum alloy, or you want to find out how stiff is steel. Let's click on aluminum and steel. When you double click on the materials, you'll find that there's a description, a series of images of what these materials are typically used for, a description of the material, typical composition of the alloy, and then a list of what we call material property. This included general properties such as density and price. So here we can see aluminum has a density of 2.7 kg per m cube, whereas the aluminum have a Young modulus around 70 gigapascal. Here, it is worth mentioning that you can also learn further. Let's say you do not know what is yield strength. You see here that right next to it, there is a column called yield strength, elastic limit, and there is a data for that materials. In fact, every single material property adjacent to it has an information tab. So let's click on it and find out what does it do. When you click on it, there is a separate window that come up that you can actually look at and read. And in this particular case, it will explain what's the meaning of yield strength, for example, 0.2% offset yield strength. What is the calculation? How do engineers usually measure it? And what is the reason a material have a higher yield strength or lower yield strength? In this case, which is governed by dislocation density. Okay, and it will talk about it from both the engineering point of view as well as from the science point of view. And after that, it will also have a list of further reading for you if you're interested in going more in depth about this topic. For example, we can also check out Young modulus. If you don't know what Young modulus is, here it will talk about what's the meaning of it, which is the initial slope of a stress strain curve of the material when it's within the elastic regime. It will also talk about the variants of type of elastic modulus, such as shear modulus and bulk modulus, and Poisson's ratio. After that, they will also talk about what causes a material to have a higher Young modulus than the other. You have learned that in your lecture, or you will have learned that in your lecture. However, if you want further understanding, this is a very good place to actually read further and understand your material science. Great. So this is the material universe. So there's two purposes of this database. One is to search out material data. So let's say you want to find out how heavy or what's the cost of copper alloy. You can click on it and you can find the density and price. Similarly, if you want to find out how expensive gold are, you can do that as well. You can go to setting and you can change the unit to any unit you want. You can change it to Canadian or US dollar. And you can also change it to euro if you want. So Canadian should be here. Yeah, there you go. And then in here, preferred unit system, you can choose to be metric or other type of unit that you prefer. You can also choose SI. In engineering and mechanics, we tend to use metric units. So now you can see that suddenly the price is in Canadian EKG. Okay, so this is the first application of using this software. The second application is to learn about material science topic. So you can click on these individual property and understand what's the meaning of it. So in your lecture, we have talked about different type of material property. And if you want to know more about it, go check this out. Maybe you want to know why material have high melting point than the other, and you can read further into this. Now, let me show you another features of this software. Let's go back to the home, and I'm going to change the database. Now, you can change the database in this browse database. Right now, we're in level 1. You can click change. After that, you can go to another database. If you are interested about design, for example, let's say you're in the architectural department, you can click on this architecture and design database. If you're interested about biomedical application, you can also click on that. So I won't show you all of them, but let's pick one for example. Let's say you are a designer and you're interested about it from the application side. You can click on this database. In this database, you can find different type of biomedical devices. So here we have dental device, we have surgery device, we have orthopedic device, and also bio stent, for example. So let me just click on a bare metal stent, and then in here it will talk about the function of the stent. What are the current FDA classification of these materials? What are the general design? And more importantly, it also tells you what are the typical material this stent is made out of. So this database basically links back to the material database. So you can then read off this typical materials. For example, in biostent, you want to typically use cobalt chromium alloy as well as nitinol. Let's say you don't know what's nitinol, then you can go back to the material universe and you can find what is nitinol, which is nickel titanium. And then here it will talk about the property of nitinol, and then you can go back and forth and then try to understand the topic further. So that's the second function of actually the third function. Now the first function is to show material property. The second function is to understand what material properties are. And then the first function is showing different type of biomedical device. Let's go to another database. Now, let's say you want to understand the deep science behind material science and engineering. You can click on this. And this actually brings you to a series of different type of topic, some of which is included in this course, and some are actually beyond the scope. Let's say you want to find out different element and find out what's the crystal structure. You can click on this, and let's say I choose one. I'm going to choose copper. I can click on the database. It will tell me what's the symbol of copper. It will tell me what's the atomic number, atomic weight. It will also tell me the groups. It will tell me the first ionization energy and second ionization energy, electronegativity. And then after that, it will show you the typical ground state crystal structure. In case of copper, we have FCC. Whereas let's say if I go to iron, there will be two different type of crystal structure. So you have alpha iron, which is at room temperature, which have a BCC body center cubic structure. Don't worry if you don't know this terminology for now. You can click on crystal structure and learn more, right? So here we can also see different type of a lot of structure where atoms like to arrange to. And in this course, we'll cover the first four, which are simple cubic, BCC, FCC, and hexagonal. While there are actually further, there are more crystal structure out there as well. So remember, these information tab are your friends. And then at higher temperature, iron actually turned from BCC into an FCC crystal structure, which are called gamma phase, which is also called austenite. And so here you can see the different type of electronic structures. And let me just bring up another element. Let's say I want to check out silicon. And then here you can see the different type of structure, and this particular one is a diamond crystal structure for silicon. Okay. So there's a lot that you can actually gain from this database. But let me just go back to the material database for now. Let me just went back to the material science, and I will show you another version. So earlier we learned about element and we learned about crystal structure. We can also learn about phase diagram. That's another topic that we talk about in the in the current course that you're in. And so in this one, it's actually very useful. It's an interactive tool that teaches you how to understand phase diagram. So you can click on this, and you will learn about a few simple understanding of what are the line, what are the representation, what are the meaning. So if you click on one, for example here, liquidus line, you can read the description of what's the definition, what's the meaning of it. You can click on another one, which is called Eutectic phase diagram. And there we have lead and tin phase diagram. And we talk about multiple lines inside these phase diagram. What's the meaning? What's the reaction? These are solid state reaction as what going on inside a phase diagram. And so we can read how, for example here, eutectic point, how a liquid phase turn into two different solid phase. And then we also have another one that are typically quite important in material science, which is called the iron carbon phase diagram, which is the main phase diagram that we need to understand for steel making, for example, and there are also different lines. Now, let's say one of the things that you really want to understand is Lever rule. You can click on here, and it will explain how Lever rules and how you can use this rule to actually calculate composition as well as the amount of phases inside this phase diagram. After that, you can also try to understand crystal structure. So here we have copper nickel crystal liquid phase. This is what I call a slushy phase, where we have liquid and solid, and then after that we have solid phase. And here we have some cartoon that help you to visualize how the material will actually solidify it into different type of structure. So this is a very simple one. Let's go to lead and tin. we can see that when you go to liquid phase to solid phase, we have this eutectic crystal structure where it looks like a zebra cross pattern, which we have green and red. And then here we have different phase. We can also look at cooling path of showing how crystal might actually grow as we cool from liquid phase. Same here, we have, this one is interesting. This is called the high eutectic reaction. And so you go on alloy. So you have liquid phase. Now you have some lead particle. The particle is growing, and then all of a sudden it turned into this alpha plus eutectic structure, which we will talk about that in the lecture. So what I want you to know is that you can learn more about this if you want further understanding of the topic. That's not the only thing that we can do. We can also go beyond the class, beyond the scope, and let's say you want to understand different type of processing. Let's say you are interested about mechanics, you're interested about robotics, you're interested about machining. So how do things put together? If you want to know about 3D printing, you can actually click on 3D printing process. You can click on this and it will tell you the description of each of the process. Let's say you are very interested about, let me see. Let's say you're very interested about molding. For, let's say you're an art and craft person, then you can read about different type of molding. One of the things that I really like to and I'm interested is, let me see if I can find it. Injection molding. So this is like a high thermal molding. This is also very interesting. So there's many things that you can do to understand conventional, so for example, band sorting. So it goes from things that you might see every day, but you don't fully understand the details, to things that are quite like state-of-the-art type of technology as well. So a lot of process that you can also learn from this database. Now, with that, I want to show you one more features that we can learn. So let's say you are trying to use selections. So you can go to materials science and you can choose selection. And then here, it will teach you how to select materials. I will go back to the level 1 and show you how I use the software to do material selection. So let's say I want to select a material that have really high Young modulus to density ratio, or have a what we call an MPI of E over rho. We can click on this. We can go to y-axis and we can choose Young modulus. We can go to we can go to x-axis, choose density. Click OK. Now we have a really beautiful what we call a material property chart, or we also call this Ashby charts, because the scientist that invented this way of visualizing material property is called Ashby, Mike Ashby from Cambridge University, which was also the founder of this software. So one of the things that I really like to do is I like to click on the family bubbles, which help me to visualize something. So here we can click on each of those big bubble to know what is the family class of these materials. And so composite and non-technical ceramics. So here we can see some really interesting behavior. We can see that turns out traditionally, or majority of the materials lie on this trend where the higher the mass density, the higher the stiffness or Young modulus of the materials. And in the lecture, we'll discuss why that is the case. And so this is very interesting, and you can click on each of those materials, and if you click on them, double click on them, it brings back to the material property chart that we see earlier. Now let's just go back to the stage, and I want to show you another features. So you can click on a index display line, and by doing this, you can now draw a line onto this graph. So earlier we talked about I want to choose a material that have high E to rho ratio, or Young modulus to density ratio. So the exponent in that material property index is actually 1. And so the slope is 1 over n, which is 1 in this case. We'll talk about that in the material selection lecture. And then you could just click on this. And you can draw it anywhere you want. Notice that this line have a y-intercept. And in the lecture, we'll explain that the y-intercept actually represents the MPI. And so anything that lie on this line means that it has the same ratio of Young modulus to density, or MPI. If I move this line further, and whoever is intercepting that line would have the same value of Young modulus to density. So let's say if I want a material that have really high Young modulus to density, I can either push this to the very high level, such that all the material grayed out. And it is worth mentioning that if you look at the left-hand side, it will tell you that show the material that passed all stage, and you see the remaining material that has passed. So here we have aluminum, aluminum nitro, CFLP, which is a composite, silicon, silicon carbide. So this is right now ranked by alphabetical, but you can actually click on this. You can rank them by density. You can rank them by Young modulus. And more interestingly, you can also rank it based on the slope that you just draw, which is Young modulus over density. Now, you'll find that right now, if you look at this value, you might want to make sure that this is, so it's actually, you can actually click on this index and you can change the order. So go descending or ascending order. And in my case, I actually want to get the highest one. And so I actually find silicon carbides have the highest Young modulus to density ratio. Alternatively, let's say I want to find another material that have the highest Young modulus or lowest Young modulus, depending on how you choose the materials. Let me just delete this graph. And I can create another one. And in this case, I just want one material property. I want highest Young modulus, okay? So I don't need to plot the x-axis. And here right now, each of these materials are different material. Each data point is a materials. And so I can read off the graph and say tungsten carbide have the highest Young modulus. Alternatively, I can click on this and rank based on Young modulus. And here, be careful because the default is actually in the ascending order, but I want the highest one, so I can double click on it or click it once and it will change to descending order. So this allowed us to actually choose material based on their material property, which is a process that we call material selection. In your material selection lecture, we'll talk more about it, but hopefully this gives you an overview about the multiple databases that are very useful for you in this Granta software. So you can use this to do material selection. You can use this to do architectural design, product design. You can use this to actually do biomedical engineering. You can use this to learn more about material science in terms of crystal structure and element. You can use this to learn phase diagram. You can learn this to do processing as well. So I'm going to end this video here, and hopefully this gives you an overview of how Granta Edupack works. If you want more details, there is a tutorial video that is created by the Granta teams, and you can click on them, and you should be able to find that from the website, from our course website, for further details of how to use this software to help you for your engineering career. All right, thank you. See ya.